Hello students, in this short video we take a look at linear equations. Specifically, we're going to look at solving some basic equations. We want to start with a definition. Recall that we actually introduced linear equations in class. So, a linear equation is an algebraic equation in which each term has an exponent of 1 and the graphing of the equation results in a straight line. Some examples of linear equations are below. Y equals 3x plus 7. P minus 9 equals 2w plus 17. B equals 0.5 times the quantity t minus 7.1 plus 8.3. In all of these examples, notice first of all we have an equation because we have the equal sign. But more importantly, it's a linear relationship because if we look at the two variables involved, the exponents on both of the variables are 1, right? If it's missing an exponent, that's understood to be 1. That makes this equation a linear equation. The second guy is also an equation, right? It has the equal sign. But more importantly, the two variables both have a degree of 1. And in the last equation, notice the two variables have a degree of 1 and we have the equal sign. So now that we know what linear equations are, let's move to the next step, which is looking at how we solve them. I'm going to take a look at a simpler equation, namely a linear equation that just has one variable. So we're going to start first with the linear equation in one variable, namely 4x plus 5 equals 17. And suppose we were asked to solve this equation. What exactly does that mean? Well, I think of solving equations like solving puzzles. To solve this equation means that we want to find the value for x that makes the equation true. 4 times what value plus 5 equals 17? It's a puzzle, and that's the question we're asking. What number do we multiply by 4 and then add 5 to in order to get 17? I want to pause really fast for a moment and let you guys think about this for a second. Well, let's see. I know that's probably not long enough, but pause it now if you want. Otherwise, I want to show you the solution. So 4 times what number plus 5 gives us 17? Well, I think what number, or in other words, x, is 3. What do you think? If we take 4 times 3 plus 5, do we get 17? Let's check. 4 times, and instead of x, we're going to replace with 3. 4 times 3 plus 5, does that equal 17? 4 times 3 is 12. And 12 plus 5 is in fact 17. That's a true statement. And that means that we have solved the equation. We call x equal 3 the solution to this equation. Now I have a question to see if I can stump you. How many solutions do you think we have for a linear equation in one variable? Actually, if this equation is solvable and is not an identity, there will always be one unique solution. So that means x equals 3 is the only solution for this equation. Not too bad, huh? Well, the problem is that not all equations are as easy to puzzle through and figure out. Let's take a look at another example. Suppose we have the equation 3.4x plus 7.1 equals 24.1. Now, that one's tricky. In fact, to solve this equation is actually going to involve more than just sitting and figuring it out with our brain. So sometimes the process of solving an equation can't be done in our heads. Particularly, this occurs when the equation contains decimals, fractions, or negative numbers. So if we can't solve these kinds of equations in our head, then we have to develop some kind of a process in order to solve it. An algebraic process, if you like. And that's where some of our key properties of equality come in. And you might remember this from middle school or or even high school, or whenever you took your first algebra class and were introduced to linear equations. There are two basic properties that help us to solve linear equations. We call them the properties of equality. The first one is the addition or subtraction property of equality. And basically, it tells us that when we add or subtract an expression or number from one side of an equation, we must add or subtract the same expression or number from the other side of the equation. When I think of an equation, I think of a balance. We have things on one side and we have things on the other side. And the idea is whatever you do to the left side, you must also do to the right side in order to keep things balanced properly. The multiplication or division property operates in the same fashion. This one says that whenever you multiply or divide both sides of an equation by an expression or number, you must multiply or divide the other side of the equation by that same number. Again, remember, equations are like balances, and whatever you do to one side of the equation, that is add, subtract, multiply, or divide, you want to do to the other side as well. But that's enough about talking about properties. Let's actually get some puzzles to solve, and let's put these properties into action. So we are going to solve some simple linear equations. Solve for the variable in each of the following equations. Now, some of these you might just be able to look at and tell me what the solution is. In fact, that first one, I think we all can just look at that and tell me what x is going to be. What does x have to be in that very first equation? 10 plus x equals 14. What does x have to be? Do you see that in that equation, 10 plus x equals 14, that x is just the value 4? Do you see that right away? Because 10 plus 4 is 14. So x equals 4 is the solution of the equation. We could just stop and be done because we know it works, and so we really are done. But let's actually practice those properties of equality on something really simple to make sure we see how they work and that we get the same solution. Using a property of equality means we want to isolate our variable x, and in doing so, we have to get rid of the 10 on the left side. So if I want x to be left alone, so if this was a much more complicated equation and I couldn't figure out in my head, I want to solve for x. That's called solving for x. And we need to get rid of the 10 that's being added to it. Well, if 10 is being added to x, well, the way to get rid of 10 then would be to subtract it. So I'm going to subtract 10 from the left side because 10 minus 10 is just 0. And then 0 plus x is just x. And so that removes the 10 and gives me an x only on the left side. But those properties that we just talked about, the properties of equality, tell us that whatever we do to one side, we have to do to the other side of the equation. So here we have the equation bars. If I subtracted 10 from the left, then I also must subtract 10 from the right. And so 14 minus 10 gives me 4. And that's where we get our solution, x equals 4. So either you just see it, or you can use a property of equality to solve and get the same answer. Let's take a look at the next example. Y minus 9 equals negative 12. Now some of you might be able to figure this out in your head without doing much work. But some of us, because we've got some negative numbers involved, negative integers, might need a little extra help. So let's decide what we can do using our properties of equality to solve this equation. Notice our goal. we want to isolate the variable, in this case y, on the left side of the equation. In order to isolate y, that means we must remove the minus 9, or the negative 9. So if we're subtracting 9 from y, the way to get rid of a subtraction is with an addition. So negative 9 plus 9 gives us 0. And the properties of equality tell us that whatever we do to the left side, we also must do to the right side. So that means I'm going to have to add 9 to the right side. And that's going to give me negative 3. On the left, I have y left over, right? I still have my y plus 0 or minus 0, so that's just y equals, and on the right side, I have negative 12 plus 9. And if you don't remember how to do integer math in your head, pull out a calculator and type in negative 12 plus 9, and you should get negative 3. If you do remember how to do the integer math in your head, you're subtracting and then taking the value, the negative sign, from the larger value, which is 12. Let's check our answer just to be sure, because that one's a little different looking. So if I put negative 3, so I'm just going to write down that I'm going to check my answer. If I put negative 3 in place of y, I have negative 3 minus 9, and sure enough, we know negative 3 minus 9 is negative 12. All right, one more simple linear equation. Here we go. 2k equals negative 30. Can you see what value k needs to be? 2 times what equals negative 30? Now, some of you might see it right away. But for those that don't, we're going to go ahead and use a property of equality to complete this equation. In this equation, notice it's not 2 plus k, it's 2 times k. When the 2 is sitting directly next to k, it means multiplication. So if 2 times k equals something, in order to remove the 2 and isolate the k, I want to do the opposite operation of multiplication, in which case I want to divide. And the property of equality tells us whatever we do to the left side, we must also do to the right side. So I'm going to divide my right side. And notice what happens on the left. Notice that when we divide, what we did was we took 2 divided by 2, which is just 1. And 1 times k is k equals negative 30 divided by 2 is just negative 15. 2 times negative 15 is negative 30, and we have solved this basic equation. All right, let's take a look at a few more. Solve for the variable in each of the following equations. The first one, 5 equals 2x plus 7. Okay, now again, it's not quite apparent what x has to be. Some people might be able to solve that puzzle right in their heads, but for the rest of us, we want to use a little bit of our properties of equality in order to come up with the correct solution. 2 times x plus 7. If I want to isolate my variable x, this time I must focus on the right side instead of the left side of the equation. And when I'm focusing there, the 2 next to the x, well, he's kind of sticking there. He's kind of attached. But that plus 7 is sitting off to the side. So we want to first of all get rid of that plus 7. That is, when you're solving linear equations that involve multiple steps, you always want to use your addition-subtraction property first. So you always want to add or subtract first. That being said, if I have 7 being added, in order to get rid of it so that I can isolate x, I want to subtract 7 from both sides of that equation. On the left side, it gives me 5 minus 7, which is negative 2, equals 2 times x, and now plus 7 minus 7, well, that's just 0. So 2x plus 0 is just 2x. And so that's the next step we have. Negative 2 equals 2 times x. We're just about finished. Do you see what we do now? After using the addition and subtraction property, that's when we do use the multiplication and division property of equality. Or in other words, now is when we multiply and divide. That's the second thing. 2 is already being multiplied by x. In order to get rid of it, I'm going to have to divide by 2. And so that will cancel. 2 divided by 2 is 1. And 1 times x is just x on the right side. Negative 2 divided by 2 is negative 1. And so that tells me x has to be negative 1. That's a simple check, so I think I'll go ahead and do that check just to be sure. Does 5 equal 2 times negative 1 plus 7? Well, 2 times negative 1 is negative 2, and negative 2 plus 7 is in fact 5. So yes, x equals negative 1 is the solution for that first equation. What about that second one? 2,000 equals 500 times the quantity 1 plus 0.04 t. This one's a little more complicated and larger. Ooh, that's going to take a lot of brain power to solve this one in our heads. Well, let me go through an extra step that we haven't had to address yet. Namely, when you have an equation or a simple linear equation and it has these parentheses or grouping symbols, the very first thing that I like to do is apply what's called the distributive property. See if that word seems familiar to you. Distributive property. I do this first, distributive property. And what does the distributive property say? The distributive property tells us that if we have a quantity times another quantity in parentheses with an addition or subtraction, we can multiply that outside quantity by multiplying it to all the terms inside the parentheses. You might have seen it like this. A times the quantity B plus C equals A times B plus A times C. Does that look familiar? Do you guys remember that from one of your earlier math classes, the distributive property? That's the one I want to apply right now. So let's multiply that through and let's see what we get. Whoops, sorry about that. Let's multiply that. I did it again. Let's multiply that through and let's see what we get. That's 2,000 on the left side, but on the right side, we're going to multiply through. 5 times 1 is just 500, plus 500 times 1 is just 500, and then 500 times 0.04 t is just 20 t. Take that on your calculator. Try it. You want to take 500 and multiply it times 0.04, and it should give you 20 t. Our equation that looked pretty complicated there has now reduced to something simpler. 2,000 equals 500 plus 20 t. What's our goal? Our goal in solving this equation is to isolate the variable t. And what did we say we do first? We always add, subtract first. So we get rid of anything that's being added or subtracted from that variable expression. 500 plus 20t. 500 is being added, so I want to remove the 500 by subtracting 500 from both sides of my equation. On the left side, I have 2,000 minus 500, which is 1,500. On the right side, I have 0 plus 20t, which is just 20t. And we're almost there. After we've done the addition and subtraction, that's when we do the multiplication and division if there are any left to do. And we do have a multiplication and division. 20 times t, that's a multiplication. And we want to get rid of that 20 by doing the opposite operation, which is dividing. So instead of multiplying, we divide. 20 divided by 20 is just 1, and 1 times t is just t on the right, and 1500 divided by 20 is just 75 on the left. Pull out your calculator and check. T equals 75 is the solution to this equation. It's not too bad when you go step by step, is it? I want to finish with two final examples. And again, these are just slightly different than the previous examples we solved. So solve for the variable in each of the following equations. The first one says 480 equals p plus 2.2p. Okay, what makes this equation different than the one we've solved before? All of the ones before, what makes this one different? Well, a couple things. First, it has decimals in it, but more importantly, do you observe that this equation, unlike the other equations, has multiple variables? Actually, two of the same variable. I have p's appearing in both this term here and this term here. Our first step, then, is we need to combine those two variables together so that I have one expression involving p. Now, do you remember from long ago in a previous algebra course, how do we combine two variables together? Yes, we add the coefficients. All right, what am I talking about? What's a coefficient? The coefficient is the number in front of the variable p. So 2.2 is the coefficient on the second term. And what about on the first term? It's missing a 1 in front, right? There's understood. When I say p, I mean 1p. So the coefficients are 1 and 2.2. And in order to combine these like terms, we put them together by adding their coefficients. 1 plus 2.2 is actually 3.2. P. Try it on your calculator. You're going to add 1 plus 2.2. You're combining or adding the coefficients. That gives you 3.2p. And that equals 480. Oh, wow. By just combining those two like terms, and I'm going to put a little word here. That way, if you need more help, you can Google like terms. Okay, and you can Google combining like terms, and then you'll be then you'll be shown about the coefficients. So like if you want something to Google, you can Google combine like terms if you want more practice. But in any case, we've got 480 equals 3.2 times p. We don't have any addition or subtraction. The only thing we have to undo is the multiplication, and we're going to undo that by dividing. So I have 3.2 times p. In order to isolate the p, I'm going to divide by 3.2. And if I do that on the right side, I also have to do that on the left side. So I'm going to cancel 3.2 divided by 3.2, and that's 1 on the right times p, which is just p. And on the left, I have 480 divided by 3.2, and 480 divided by 3.2, pulling out our calculators, or Desmos. Gotta love Desmos, right? 480 divided by 3.2 is just 150. That means 150 is the solution of this equation. And we can always go back and check by plugging it in to making sure both sides are equal. This brings us to our last equation for the day. X minus 4 over 2.2 equals 1.85. X minus 4 over 2.2 equals 1.85. We're solving for x, but notice this one's a little different, and you've already turned your brains off. Well, no, I'm just teasing. Fractions, oh my goodness. Okay, so what are we going to do with this? All right, so I have x minus 4 divided by 22 equals 1.85. There's lots of ways to approach this problem, lots of things to see. One thing that is missing, which we don't see, but which is inherent in this problem, is the fact that there are missing parentheses around this x minus 4. The x minus 4 is all together in the numerator, or in other words, all of x minus 4 is being divided by 2 minus 2. If this is the case, really, we want to first of all get rid of the 2 minus 2 before we can get rid of that minus 4 in the parentheses. So we first have to deal with the outside portion, which is the 2 minus 2. Now notice, 2 minus 2 is being divided from that quantity. And so what I need to do is I need to apply the multiplication division property, but because 2 minus 2 is being divided, what I need to do to get rid of it is multiply. Namely, let's see if this looks okay. So I have x minus 4, and I'll just put those parentheses around because that's really what's happening, over 2.2. And what I'm going to do is I'm going to multiply the left side of the equation by 2.2, or if you like, 2.2 over 1. And I'm going to multiply the right side of the equation by 2.2, or if you like, 2.2 over 1. What does that do on the left? Well, that allows us to cancel because 2.2 divided by 2.2, or if I like, 2.2 over 2.2 is just 1, and 1 times x minus 4 is just x minus 4. So the left side just becomes x minus 4. On the right side, we have 1.85, and we're multiplying it times 2.2, and that's going to give us 4.07. Check and make sure we did that right. So 1.85 times 2.2 is 4.07. And now we finish, and the way we do that is to isolate the x, we have to get rid of the minus 4, so we're going to need to add 4 to both sides, and if I do it to the left, I'm going to do it to the right, so I'm adding 4 to the right, and that's giving me the final answer on the left of x plus 0, or just x equals, and on the right, 4.07 plus 4, or 8.07. If we take 8.07, subtract 4, and then divide by 2.2, we should get 1.85. Well, okay, so I said it was going to be a short video, but it turned out to be a longer video than I anticipated. But that's because I had a lot of examples that I wanted to show you, and they took a little longer than I wanted. But that being said, I hope that this was good. I hope you got a basic idea and understanding of how to solve some simple linear equations. In class, we're going to practice some more and as well look at how to graph them on the XY plane. So have a wonderful day, everyone, and enjoy solving some linear equations in your homework.